Hello, and welcome back for the review for chapter 4. I will be doing these in some groupings of problems. They won't be all in the same video. So the first one I'd like to work on today is finding that the functions are inverses of each other. If two functions are inverses of each other, then if you compose one with the other, they should equal x. Okay. So if I compose f with g, that means g is going into the f of x function. So 4x minus 5 plus 5 over 4. G is my input into the f function. Then those cancel, and I'm left with 4x over 4, and I get x. Then I also have to show that g composed with f also works. So that means 4, in place of x, I'm putting x plus 5 over 4 minus 5. So my 4's cancel, and again, I'm left with x plus 5 minus 5, which simplifies to x. So yes, they are inverses of each other. So this is what I would expect to see on your papers to show that they compose with each other and create x. So number 2 is finding the inverse function of f of x equals 3x to the 5th plus 1. So for this one, when we have the inverse, what I do is I set this equal to y, and then I switch out my x and y. So this is 3y to the 5th plus 1 equals x. And then I'm going to solve for y. And so to do that, I'm going to subtract 1 from both sides. So we'll have 3y to the 5th equals x minus 1. And I'm still trying to solve for y, so I'm going to divide by 3. So we have y to the 5th equals x minus 1 divided by 3. And then to undo the 5th power, I can use the 5th root. So y equals the 5th root of x minus 1 over 3. And then it's the function of. So my inverse function of x is equal to the 5th root of x minus 1 over 3. So these are kind of the steps that I would expect you to follow on a problem of finding the inverse function. Sketching a graph of these functions here, I'm just going to go over the answer key because I would expect that you're going to look these up in Desmos, and then you would just draw me a quick sketch on your paper. Because remember, on the test in the Lockdown browser, you cannot save your Desmos. So anything you do in there, you have to be drawing on paper, a rough sketch. So because this function is an increasing function, we know it's going to be increasing in a general picture. And the regular exponential function has an asymptote at 0, but because afterward we're adding 1, we're shifting that up. And so our asymptote is at 1. Then number 4, that function is going to be a decreasing function because it is reflected over the x-axis. And so again, I would expect that you would put this into Desmos and then look and get a general picture of the graph to ask those questions. Number 5 is asking us to write this in exponential form. So remember, when we read this line right here, it says log base 3 of 1 over 27 is a negative 3. So whatever your base is in the log form, it's also the base in the exponential form. So that means I have a base 3 in my exponential form. And I'm to the power of a negative 3. And that equals 1 over 27. And you can validate this in Desmos. Number 6 says, write this exponential form in log form. So again, this is base 16 to the 1/4 power equals 2. So it's going to be log base 16 as a subscript here of 2 equals 1/4. The exponent and the equals switch positions, and then the base and the exponential is the same as the base and the log. Number 7 is asking you to evaluate this without using a calculator. So log base 25 of 5 is x. Okay, so what I would do is I would rewrite this in exponential form. It's base 25, so I'm base 25. So what power of 25 could I do to result in a value of 5? Excuse me. So my power of 25 that I could get to a 5 is 1/2. So when x equals 1/2, and that's because 25 to the 1/2 power is the same as the square root of 25. And that results in 5. So I would have to have x as 1/2. Catch me back for some more videos of this review, starting with number 8.